Day 14 of 90. Run Terraform show on most repos and you'll find something terrifying: your RDS database password, sitting in plaintext, inside a state file that lives in an S3 bucket forever. Today we turn a tangled multi-module Terraform repo into a hardened, auditable foundation, where secret injection, network boundaries, and policy guardrails are wired directly into the IAC layer, so no engineer can accidentally ship an insecure baseline. Let's build it. Here's the problem in one frame. A monolithic main.tf with a hard-coded AMI, a plaintext db_password variable, and a catch-all security group opening port 22 to 0.0.0.0/0. Module boundaries are meaningless. Hardening is a checklist nobody runs. So every new cluster ships the same known weaknesses as the last. The fix isn't more discipline, it's making the insecure path impossible at plan time. Step 1. Decompose. Split into 3 security-aware modules: modules/network, modules/compute, and modules/secrets, composed by a thin root main.tf. Module boundaries aren't organization here, they're a security primitive. Each module gets an explicit variable contract. Watch this validation block: variable environment with a condition that contains prod, staging, var.environment, and db_password with length, var.db_password, equals 32. An unsafe default now fails at plan, not in production. Step 2. Kill the plaintext secret entirely. Inside modules/secrets, instead of passing a password as a string, use the Vault provider's dynamic credentials, vault_AWS_access_credentials. The AWS keys are ephemeral, generated per run, and never written to Terraform.tf state. If you're on AWS native, swap in a data AWS_secretsmanager_secret_version lookup that fetches at plan time. Mark every output sensitive equals true. Now run Terraform plan, the value shows as sensitive value. It never touches state, never hits CI logs. Quick refactor tip so you don't destroy live infrastructure doing this. When you move a resource into a module, add a moved block, moved from AWS_instance.db to module.compute.aws_instance.db. Terraform treats it as a move, not a destroy and recreate. Verify with Terraform state list before and after, same resources, new addresses, 0 downtime. That's the difference between a refactor and an outage. Step 3. Enforce it at the boundary with policy as code. We render the plan to JSON, Terraform show JSON plan.bin plan.json, and run conftest against OPA policies. 3 rules. 1. Deny any AWS_instance without an encrypted root volume. 2. Deny any AWS_security_group_rule with CIDR 0.0.0.0/0 on port 22. 3. Require every resource to carry cost center and team tags. Run conftest test policy/policies plan.json against a bad plan and you get a red fail with the exact rule and resource. The pipeline stops. Wire that into CI so it's not optional. In GitHub Actions, a single step, run conftest test policy/policies/plan.json. Non-zero exit fails the job, the merge blocks. Layer tfsec or a custom.tfsec.yml on top to catch any variable named password or secret being referenced directly. Now hope nobody hardcodes a key, becomes a plan time enforcement guarantee, machine checked on every pull request, every engineer, no exceptions. Day 14 done. The takeaway: module boundaries are where you enforce security, not just where you organize code. Variable validation rejects unsafe defaults, dynamic secrets keep sensitive values out of state, and OPA at the boundary blocks non-compliant plans before apply. Run the full pipeline, plan, conftest gate, apply, against a compliant config and your state file is clean. No secrets, no open SSH, no untagged resources. Subscribe for day 15.